So we want to convert the Cartesian coordinate to a polar coordinate. We have the Cartesian point and we want to convert those points into a polar points. And the polar point starts with a radius and a theta. And the Cartesian, we know that it's an x and a y. So how to do that? Let's plot those. So x in this direction, -1, y down because it's a negative. And is radius the same as a hypotenuse? Yes, it is. So that's really easy. I would use Pythagoras. So this is the radius, which is in black. R squared equal y squared plus x squared. I'm using the exact same formula as the Pythagoras. So then I would plug the values that I have. But first, I will get rid of the square root, which will be r equals square root. R equals square root. Y is -1 squared plus -1 squared, because x is also -1, which would give me square root of 2. So I found the radius. The radius is square root of 2. So let's find the theta, or the degree. And I would use this point, this theta, this degree. And we know I can use tan, I can use sine, I can use cos, but I'm going to use tan in this case. I'm using the 2 point that they already gave me. I won't use the point that I found. And tan equals sine over cos. And sine is always the opposite. Cos is always the adjacent, because SOA and COA. Yeah, SOA, which is like that. That's opposite, adjacent. I use this to memorize it. So a tan inverse would give me y, which is in this case -1, because it's sine, the opposite, and the adjacent, which is x, -1, which would give me pi over 4. But pi over 4 is in this part, which all values should be positive, but I have all values negative, so it need to be this part, which is the third. So what I'm going to use is add pi. So when I would add pi, it will give me 5 pi over 4, and yeah, this degree is in this part of the circle. So it will be pi over 4, 5 pi over 4, and this is the polar coordinate.